have me, or unlucky enough, because this could be a messy section. And as I said before, we're going to be looking at the science behind this amazing vegetable. It's not red, even though when you go into the shop, there's a big sticker normally on here that says red cabbage. And you've got to be careful here, because whenever you chop this cabbage up or pull it apart, you're going to find that your fingers will end up going purple as well. So you can put gloves on at this stage. But all I want you to do is to get a little jug, and you're going to cut or tear your cabbage into tiny, tiny pieces. So here we go. So my cabbage is going into there. And then we're going to boil the kettle. And this is going to be a job for mummy or daddy or granny or granddad, whoever the serious adult is in your household looking after the younger ones. And when we cut this all up, we are going to then steep it in the water, and this purple colour will come out into the solution. So we could do that and then eat the cabbage. Cabbage would be good. If you've got a blender, you can blend it. All these kind of crazy things that we can do to get this purple colour out. So here's my kettle here, and I'm going to pour the water on there. Now, some of you may find that instead of being purple, it goes blue. And we're going to find out about that in a minute. But still doesn't explain why it is called red cabbage. So now, we're starting to see that's getting coloured. I'm a lazy scientist. So what I've done, and this is going to be in the shop, what I've done is I've dried hundreds of cabbages and I've turned them into a powder. That means I only use the amount that I require. And just to make it look a bit silly, here's one of my little cafetières. I'm going to pour the powder into there. I'll put it all in, and then I'm going to pour on some of the water. There we go. And we've got that lovely kind of purple colour coming in there. I'm going to add in some more water. There we go. And then, to make sure I don't have any of the bits, I'm going to use the sieve section here that normally keeps all the coffee grinds in our cafetiere. So what I've got here now then is my juice. And this juice could be a magic potion. We don't know. We can go into all the drama and learn about the science now. And then you can go away and maybe do a little piece of drama for the other people that haven't seen this show. We're then going to need some cups, some glasses, or we can use test tubes. So I've got some test tubes there, and I've got some smaller test tubes here. These ones are quite good because they've got little lids on there, which means if it gets knocked over, nothing gets spilled. But I'm going to use these ones here because they are a little bit bigger. And when I do this, then I'm just going to pour my juice into the test tubes. That's 1, 2, 3, 4, 5, hopefully we're going to have enough for 6. There we go. Wonderful. And what you can do is, instead of using test tubes, we can just have beakers, clear beakers. Well, these are stuck together, big pull there. Clear beakers, the medicine cups that we get whenever we have our Calpol, or even glasses. But if it's glass, then we have to make sure that none of them get knocked over. Now, I've gone through various chemicals in my kitchen, and this is where a little bit of science and safety has to come in, because some of the chemicals have got danger symbols on them, and you're going to be surprised on some of them that have this symbol. I couldn't see that for a minute. Look at this, fairy liquid. In fact, all of our washing up liquids have got this symbol on. And this means if you've got delicate hands, that you could end up getting very sore hands if you keep it in that solution for a long time. It means it's an irritant. But it's an irritant because it's a strong alkali which is there to clean. And another one that has got that symbol on, there it is there. It's not as big as I'd like it to be, And this is washing soda. And fairy liquid, washing soda. I've got another soda that I've got from the kitchen. Baking soda, bicarbonate of soda. Sodium bicarbonate, it's got lots of names. No danger symbol here. So this one here, all the kids can use, but not the other ones unless adults are there. And unless we are wearing some safety equipment. Now these are quite good. Except I can't see anything inside. Swimming goggles are really good. Or you can get safety glasses. And for the small heads, I like this one here because it straps on. And it doesn't matter how big, oh, look at the state of my hair, how big or how small you are, then those safety glasses are going to stay on your head. Another symbol that we might see, because we could just go around the house and look at symbols for the moment, is this one here. I'm not going to be using any chemicals today that have this symbol. That lets us know that it will burn really easily, and so it's called flammable. So have a look and see what you've got at home that is flammable. You might be surprised. And the last one I'm going to use is this one here. And this is very dangerous because if any of these liquids go onto our skin or in our eye, we're going to get a nasty burn. Again, go through the kitchen cupboard and find out if you can find anything with these on. Now, one of the ones that I've got here, this is a very strong acid and it's for descaling my kettle. There's the symbol, very small. I wish it was much bigger. This is why you have to go hunting for them. And I've got another chemical here. This is here. And it's called caustic soda, sodium hydroxide. And caustic soda is also used to clear drains. So these two chemicals here, I'm going to use, just so we can kind of have a look and see some of the science behind it. But adults only, because the danger is severe. So we don't want to get any burns. But do find out at home which ones have these symbols on so that you know you're always going to be safe. You know what you can use and what you can't use. So I mentioned this one here. This is a really, really strong acid, but we do have acids at home that are not that strong. So I've got vinegar. No danger symbol on there. If I've got a cut on my hand, yeah, it's going to be sore, but it's not going to be dangerous. It's the same as lemon juice. We can try some lemon juice, etc. And I've got another one here. This is called citric acid, and we would get it on those crazy sweets. Oh, what are they called? Toxic waste. Have you tried those? Adults, if you haven't tried them, don't. You suck them, they're really sour. They're even more sour than vinegar and they turn your face inside out. So I've got the three acids here. I've got the really, really, really strong one, the deadly one. I've got my citric acid here and I've got my vinegar. But if they're not labelled, if I have them in cups and there's no labels on them, how am I going to know which is the strongest and which is the weakest? And this is where the cabbage comes in handy. I'm just going to top this one here up with a little bit more water. There we go. And so the more water we use, the lighter the colour will be. Oh, but this one here, this is going to be our control. This is water. It's not acid, it's not alkaline. So that's going to be there. And what I'm going to do now is I'm going to add some water to my washing soda. I'm going to make a little solution here. I'm going to stir that up. There we go. And I could pour this in, or I could use a syringe, or I could use a pipette, and we can get those whenever, again, we've got Calpol, they've got lovely little syringes that we can get there. But let's just have a look and see what happens here. So when I put in the washing soda, do you see that? We've got a colour change already. We've got a lovely green colour. And again, if I water it down, then that colour gets lighter. This is neutral, it's purple. This lets me know that I've got an alkali. It's a lovely green colour. Now, what I want to do now is I want to try another one that's safe. So what I've got here is my baking soda. So let's have a little test here. So my baking soda, that's going to go into a cup. There we go. I'm going to add some water to this one here. There we are. And just so that we can see, I don't need to use test tubes. I can just use these little beakers. And let's pour in some of our cabbage juice. And I get blue. I've got a cabbage juice that I call red, but if it gives a weak alkaline, I get blue. And as it gets stronger, it goes to be green. Now, the strongest one that I had, this is this one here. This is my caustic soda. And because it is so dangerous, I'm going to have to put on my safety glasses. So here we go. Just in case there's any little splashes, like a little frog. I'm going to put in my water. Always keep it away from my face. And what you'll also notice with this one here is this solution also gets very warm. It's very warm. A lot of heat energy is given out from this one. Another reason why it's so dangerous. I'm going to give that a little stir. And this time I'm going to add it into this one here. So with my washing soda, it was green. Let's see what I get with my caustic soda. So it starts off green. Does anything else happen? Is that green the same shade of green that we started with? Or is it getting lighter? Now, let's have a look. They're definitely different. And this one here is getting paler and paler. And eventually it will give me a yellow colour. Now I'm going to pour all of that liquid in there so that we can end up with the heights being the same. I'm weird that way. Maybe that's why I'm a scientist. There we go. So all my heights are the same. And what we've found then is whenever we are using it's very warm in here. They've gone all kind of foggied up there. I've got blue if it's baking soda. It's a weak soda. It's an alkali, a weak alkali. As I go into my washing soda, it gets a little bit more dangerous, which is why we then end up with that irritant symbol on there. And then with caustic soda, well, on the caustic soda tubs, we will see this symbol here. Cabbage juice allows me to know which one is safe and which one is dangerous. It's got a chemical in there. It's called anthocyanin. It's a pigment. And as the alkalis get stronger, it plays with the amount of light that comes in and goes out and changes the colour. So we've got yellow. If it's a very, very strong alkali, we're going to get green. If it's a weaker one, but still a bit of an irritant. But if it's safe to use, we're going to get blue. And if it's neutral, we're going to end up with this lovely purple colour. Now, I've got some vinegar in here, and I'm going to pour in some of my cabbage juice. So watch very carefully, watch very carefully. What colour do I get? It's exciting, isn't it? It ended up with red. It's a very pinky red at the moment. So what happened years and years and years ago, before we were able to freeze our vegetables, the cabbages would grow, and for me to be able to keep them so I could eat them later on in the year, we pickled them in vinegar. And when it went into the vinegar, it went red, and it was like magic. And I went, wow, this is a crazy vegetable. So we now call it red cabbage. I've got my citric acid here, so I'm going to very carefully take the lid off, pop it off, and I'm going to put some of these crystals into here. Again, this is one of these chemicals that we can eat, so therefore you're not going to see any of those danger symbols on there. I'm going to put a little bit of water in, and just like sugar, these crystals will start to dissolve. They're going to be bombarded by the water molecules, and they're going to break down and mix in with the water. Let's try and see what we're going to get here. So when I put that in there, oh, that one's another shade. Look at that. Oh, no, they're exactly the same. So how am I going to tell the difference? Well, let's put that down there. I want to put the vinegar in this one here. Let's put the vinegar in there. There we go. That's nice. And this time I'm going to put the stronger acid in here. Boys and girls, what did I nearly forget to put on? My safety glasses. So here we go. Let's hope they don't get fog up this time here. So when I put that in here, let's see what happens. Oh, definitely red. So what we've got here then is when it's really, really strong, we can get a bright red, but the color difference really isn't as clear as we get with our alkalis. So that's my strongest acid. That's my citric acid. And let's put a little bit of our vinegar in here. Oh, that was our vinegar. Ooh, I'm getting confused here now. I have to have a little smell. No, that's my citric acid. And here we go. Let's put our vinegar in there. It doesn't really matter. I just want us to get a range of colours. There we go. Now, so cabbage. Cabbage allows me to find out if I've got an acid or an alkali. It's a very dark red if it's a very, very strong acid, and it's going to be a very bright yellow if it's a very, very strong alkali. As the acid gets weaker, we're going to just go into various shades of reds and pinks. So it's not that easy for me to distinguish between the strengths of the acids. But when we go into the alkalis, we get greens and we get blues. And this also allows me to dye materials in different colours. But that's not what I said I was going to be talking about earlier, is it? I said we were going to be looking at bubble bath. I'm very excited about this because this is one of my new chemicals that I have in my shop. But before we do that, I've got this shower gel. So we're going to put some of this shower gel into some water, and we're going to test it with our cabbage juice to find out if it is acid or if it is alkaline. So I'm going to give that a little stir. There we go. And when I put in my cabbage juice, well, what colour do you think it's going to go? Any idea? Should we see? Here we go. It stays purple. Whenever we've got soaps that are going to be used for young children, we'd make sure that they are neutral. So that's another good thing that we've got here. And we can mix acids and alkalis together so that they cancel each other out and it becomes neutralized. And I think that's what we're going to do right now. So let me just bring this closer together and let's see what happens when we get neutralization. So first of all then, I'm going to pour some of my baking soda solution into here. There it goes. And then when I put some of my acid in, whoa! Oh my goodness! Did you see that happen? It neutralized, but I also got a gas. No way! We've just made a bath bomb, but a bath bomb without the soap. Right, I think I'd like to do that again. Right, let's get rid of this. Let's start with this here. So that's got the soap in. Let's put in some baking soda. Right, let's put some baking soda in. So we've got the soap and it's still purple. Put in the baking soda. Uh-oh! And we've gone blue. What is going to happen when... Now, I know it's going to fizz this time. So what am I going to have to wear? Yes, my safety glasses. Bing! Are we ready for this? Oh my goodness, I'm scared. You scared? I'm scared. Here we go. 3, 2, 1. Whoa! Look at that. We've ended up with a big foamy mess using chemicals which are safe. I didn't use the vinegar because in a bath I would smell like fish and chips. So this is why the citric acid is so good to use, because it doesn't have a smell. Right, I think we should do all of that again, but this time using this chemical here. Now, I want to move all of these things out of the way. I'm going to move that out of the way. There we go. And I'm going to move in a larger container. Little bowl, plastic bowl. And I think we should really use much bigger quantities of water. So first of all, inside here, it doesn't have cabbage juice because cabbage is a little bit smelly as well. It's got a chemical called bromocresol green. It's green when it's neutral. Is it green at the moment? No, it's orange. And the reason it's orange, I was looking here, it's also got citric acid in here. Now, let me pour some water in here. And then we're going to add in our bubble bath. That goes in. There we go. Still a little bit orange at the moment, but let's give it a little stir. And when it goes into the water, we then get that lovely green colour. If I add more citric acid to it, then hopefully we're going to get it to change colour again. So I put the citric acid in and it goes back to that orange colour. Ooh, it's like magic, isn't it? Now, for me to get these chemicals to give me a fizz, I was about to say buzz there, we're going to have to put in our baking soda. You can make your own colour changing bubble bath using cabbage. Make sure it's nice and fresh so it doesn't have that smelly cabbage smell. Or you can buy the colour changing bubble bath. It doesn't matter which one, they're both fun. And you can use it then to make bath bombs, because when we add in the baking soda, the sodium hydrogen carbonate, it reacts with the acid to release carbon dioxide. But because it's got that bromocresol green in there, it's then also going to give me a colour change. It's orange in an acid, it's green when it's neutral, and when we put in, oh my goodness, our baking soda, we end up with a lovely blue colour. I'm Scientific Sue. Mums and dads and adults and grannies, if you need any help, you can contact me, Science to Life. You can email me and I will give you all of the science that you need to be able to go through this science much more slowly than I have done. I will also put this up on my YouTube page so you can go back to it again and again and again and kind of just play with our science. So I'm Scientific Sue, and thank you so much for watching and staying watching. Woo-hoo!